Welcome to our video where we're going to be going through the solutions for College Board's Practice Test 10, which is available for free on the College Board website, which you can find in the description to this video. Our best recommendation is for you to go ahead and try the questions on your own and then look to this video for solutions on the ones you've missed. Or you can go ahead and pause this video every time you see a new question, try the question, and then cross-reference your answer against ours. So starting with number 1, nice and easy sort of beginner level problem here. We're just finding the value of z. And we're just going to go ahead and start by taking away 2z from both sides. So we have 1 equals z minus 2z, which is negative z. And now we can multiply or divide both sides by negative 1. And we'll get z on this side and negative 1 on this side. And so the answer is negative 1, which is B for boy. Moving right along to this question here. We have a television with a price of $300, has an initial payment of $60, weekly payments of $30, and we're looking for the equation. So this is just your classic y equals mx plus b situation. So we have the initial payment of 60. So just going into linears in general, you have the starting point of 60 and the weekly payments of 30. So the starting point, that's your y-intercept, and the rate of change. So the money is going to change by 30 for every week that goes by. That's your slope, your rate of change. So just for a nice simple question, that would give us 30x plus 60 as the basic equation. Now maybe keep your eye open for conflicting units, which would change the story. But as long as the time increments are only weeks, then we're kind of good to go here with that. And now the next thing is saying that the price of the whole thing, so the amount of money this all needs to equal in the end, is 300. So we'll set it equal to 300. And now we have a nice equation that we can start solving. So take away 60 from both sides and divide both sides by 30. So take away 60 from both sides and you get 240 and not 246. And 240 divided by 30 is 8. And so we didn't even need to go that far because this was what they were asking us to do. But you can definitely expect some problems down the line where they go ahead and solve all the way to get the 8. So the answer to number 2 is C. Moving right along to number 3 now. So we have the table above is giving shipping charges. There's a function that's going to determine the total shipping charge with the weight being X pounds. So we have a nice linear situation here. We could test that out by finding out if every time X changes by the same amount, does Y change by the same amount? So if we ever needed to on a question, we could test that out. But here we're just being told that it's linear. So they tell that to us right here. And so the nice first thing you could do in a question like this is solve for the slope, which is going to be y2 minus y1 over x2 minus x1. So your independent variable is going to be your x right here. The weight is kind of the determining factor. And then the y, the dependent variable, is the thing that changes every time the weight changes. So I could take these two, let's say just the first 2 points, 5 and 1694 and 102189, and just go ahead and plug those in. A nice easy way if you're a beginner to finding slope is to just label them x1 y1, x2 y2, and so that'll be 2189 minus 1694 divided by 10 minus 5. And we can go ahead and calculate that out. So this is the non-calculator section. So it has kind of the annoyance of just kind of having to do this work here, which is fine. But, you know, not that annoying in the sense that we all should be able to do a lot of this kind of stuff, right? So we've got 9 minus 4 is 5, 8 minus 9, you can't subtract, so 18 minus 9. So you get a 9 right here. So we have to go ahead and make this a 0, bring it down by 1 because we borrowed, and add a 1 there. 10 minus 6 is 4. Sorry if that's not properly aligned. And this becomes a 1, so 1 minus 1 is 0. So you get 495 on the top, 4.95 on the top, and 5 on the bottom. So you have 495 over 5, which is, now, by the way, that's a fraction that has something slightly smaller on the top than on the bottom, just by a tiny bit, because that's 4.95 divided by 5.00. So, you know, for me to get a number like 3, the numerator has to be 3 times bigger than the denominator. So it's definitely not that. So we already know that the slope out of our choices has to be 0.99. And we've already narrowed this question down to this one or this one. And now we're just looking for the y-intercept. So okay, when you're finding the equation of a line, you're either going to be given the slope and the intercept, which means that you should use y equals mx plus b, which is called the slope-intercept formula of a line, or a point and a slope, which means that you should use the point slope formula of a line. Y minus y1 equals mx minus x1. And so here we're not being given the y-intercept, so we're not going to use this one. We're going to go ahead and use this one, and you can pick whichever point. I would say pick the one that's just the easiest one. So we'll go ahead and use these 2 points because they're the smallest, so therefore the easiest. And we can say y minus 1694 equals 0.99. We figured that out by process of elimination. X minus 5. So we put the x and the y in the x1 and y1 spot. Now we're just distributing. So now we have 5 times 0.99, so a little more of that work that needs to be done. So 45 and 49, 45 plus 4. So we have 4.95 there. And now we're going to add 1694. So now when you're adding a positive and a negative, there's a 3-step rule for that, which is to say you can ignore both of those signs, subtract bigger minus smaller, and keep the sign of the bigger one. So we'll go ahead and just do the subtraction there. So that's 1694 minus 4.95. So the 3-step process for adding things with opposite signs, which is what we're doing here, is you forget about the signs of both, subtract the bigger looking one minus the smaller looking one, and keep the sign of the bigger looking one. So the answer here is going to be positive. And so we have 14 minus 5 is 9. Reduce that to an 8, add a 1. 18 minus 9 is 9. Reduce that to a 5, subtract 5 minus 4 is 1. And bring down this 1, and we have 11.99. So the answer is 0.99x plus 11.99. And that matches choice B for number 3. Moving right along now. So we have this line right here. One thing to always look out for is to make sure the origin's the actual origin. A lot of times the line will be like right here and right here. So it'll look like this is the y-intercept, and that'll be incorrect. The y-intercept is going to be the place where x is 0. So just something to look out for, something we've noticed on a lot of SATs. But looking here, we have the diameter in feet and the height, which is h of x, which is the y. So your f of x is just a fancy way of saying your y. How much greater is the height of a column that has a diameter of 5 than the one that has a diameter of 2? So when the diameter is 2, the height is 14. And when the diameter is 5, the height is 35. So how much greater is that? It's 35 minus 14, which is 21. So the answer to question 4 is going to be C. Going over to number 5 now, we have the square root of 9x squared. So now when you have a square root, you have a plus and minus answer. So for instance, the square root of 25 is plus or minus 5. And that's the reason why they're telling us this, because mathematically you should actually be getting 2 answers, and they're going to tell you at the end, this is how you select one of those answers. So this is like saying we have the square root of 9 and the square root of x squared. So square root of 9 is plus or minus 3, and the square root of x squared is just x, right? That's actually an important thing to kind of know off to the side here. The square root of x times the square root of x is x, because the longer way of saying that would be the square root of x times the square root of x is the square root of x squared. Now, a square root and a square are opposite operations, because if I say square root, I'm saying what number multiplied by itself twice equals the thing under that radical. But if I square it, I say I'm multiplying it by itself twice. So those undo each other, which is why you get that nice single x there. But so then in our situation, we have the x. So the answer really is plus or minus 3x. And they're telling us pick the positive one. So we'll say A right there for number 5. So going on to number 6 now. What are all the values of x that satisfy this equation? Okay, so they're asking you about undefined, in part about undefined values here. Undefined values is when you have a 0 in the denominator, or you have a negative under a radical. So we know looking here that if I put a 1 in the place of x, we'd have a 0 in a denominator. So x cannot equal 1. But aside from that, what else can we do? X squared minus 1 right here is a difference of squares. So you're supposed to know going into an SAT that a squared minus b squared, this is a difference of squares. It has a minus sign. That's our difference, because subtraction is called difference in math, right? And a squared and b squared both are perfect squares, because the square root is a nice, beautiful number. So it's a difference of 2 squares. So similarly, I have x squared minus 1. I have the minus sign. I have a perfect square here and a perfect square here. So that's a difference of squares. And that's going to factor to x plus 1 and x minus 1. Still over x minus 1 equals negative 2. So a little more about the difference of squares. Like, how do we just know that a difference of squares factors that way? A squared minus b squared would have factored to a plus b, a minus b. Now, how do we know that that's the case? You know it's the case through familiarity, through having done a lot of these, and you should. If you are maybe not familiar with this yet, you could go to a website called CUDA. So just type in Google CUDA and type in a topic like difference of squares, and you'll get a little worksheet with questions. Now, we're not affiliated with CUDA, but they make great worksheets. And so you should be able to go through so many of these that you just kind of know. Like, for instance, I know from having done a lot that if I have 25 minus b squared, well, that's a difference of 2 perfect squares. It's a minus sign in the middle, and 25 and b squared are both perfect squares. So I know it's going to factor to 5 plus b and 5 minus b. And part of the process of learning that and just having it so down is foiling out the answer and realizing that every time I have the same 2 things with a plus and a minus, and I multiply them out, first times first for FOIL, first, outer, inner, last is the way you multiply this. First times first, outer times outer, inner times inner, last times last. So that comes out to 25 minus b squared. So we do so many of these that we know that if you ever are multiplying something like this with the plus and minus, the outer and inner terms of the foiling are going to automatically cancel each other. And so that's why we won't even write it. We'll just do 25 minus b squared, having done a lot of those. So that's a little aside about differences of squares right there. And that's the reason why we know that the x squared minus 1 factors to x plus 1, x minus 1. But now if you have an x minus 1 on the top and on the bottom, it's going to cancel away. And we get x plus 1 equals negative 2. Take away 1 from both sides, and x equals negative 3. So the answer here is going to be negative 3 for number 6. So that's A. Going over to number 7 now. The graph is shown in the plane. What's the value of f of 0? So when we see f of x f of x is just basically y. But why are we saying f of x instead of y? Because it's y at some x value. So for instance, if I have like y equals 2x minus 3, that's my equation. But there's no notation built into that for me to say, okay, what's the y value when x is 5? But if I, instead of calling it y, I'm allowed to call it f of x. F of x is 2x minus 3. That has kind of just a structure built in for me to be able to say, okay, well, what's f of 5? And that's 2 times 5 minus 3. So when I say f of 5, what that means is it's the value, the height of the function when x equals 5. So here in our example, f of 0, they're asking us what's the height of this f function when x equals 0. And so we can just look and see, okay, well, x is 0 anywhere along this line. This is a line of all the points where the x value is 0. And so the height of the function when x is 0 is 4. And so the answer is going to be D for number 7. So now a good thing to know, this is kind of level 1 of an f of x type of question, but a question would easily give you something with 2 pieces. That's kind of something that's been coming up a lot in SATs. What's f of a plus b? So a lot of people, if I give them f of 5, they'll immediately know that means 2 times 5 minus 3 here. But if we say f of a plus b, you want to be really comfortable saying, okay, well, that's 2 times a plus b minus 3. Or if we want to make it even more complicated, what's f of x minus 5? Because the original one has an x and the new one has an x, it can be a little sort of tricky if you haven't seen it before. But that would just be 2 times x minus 5 minus 3. So when you have an f of x statement with something substituted into the x area, it just simply means substitute x with whatever you have in the parentheses. So that's number 7, and the answer is D right there. Moving on to number 8. Okay, point B lies on AD. One thing I'd like to point out is that this is absolutely unnecessary because we can see that point B lies on AD. Well, what's the value of 3x? So there's a couple of ways to do this. The idea is that all of these angles have to add to 180, because if you add up all the angles that form a straight line, which in this case is the AD as our straight line, all of those need to add to 180. So we have 90 right here. So we can say 90 plus the x and the 2x and the other 2x should equal 180. So we can combine like terms and all the x's become 5x right there. Take away 90 from both sides. And now we have 90 divided by 5. Subtract right there. And 90 divided by 5 is 18. So x is 18. So what trap can we fall into here? We can just circle 18. If we're in a rush, if we're not focused, if we're not relaxed, we might fall into that mistake. And I've been known to do that even myself. But the question is not asking us what x is, it's asking us what 3x is. So 3x is 3 times 18, which is going to be 54. So the answer for number 8 is C. Now we're going to number 9. Which of the following is an equation of line L in the xy plane above? Okay, so line A, it's a line, of course. It's a y equals mx plus b. And the m is your slope, the b is your y-intercept. So where are we hitting the y-axis? We're hitting it at -4. And what's the slope? Well, the slope is your change in y over your change in x. Change in y is the same as saying y2 minus y1, and change in x is the same as saying x2 minus x1. But here we can, when you're given a graph visually, so when you're given a line and you're being given it visually, think of your slope as the change in y over change in x, as opposed to the slope formula, y2 minus y1 over x2 minus x1. Because thinking of it this way allows you to say, well, what's my change in y and what's my change in x? And a very important thing about this formula is that slope is change in y over change in x as you go from left to right. Teachers don't really emphasize that quite enough. So it's your change in y over change in x as you go from left to right. So the way to do that is to say, okay, well, this is point A, this is point B. So as I go from A to B, from left to right, how much is the y changing? How much is the x changing? So the y is going down by 4. So what's our rise? It's not a rise, it's negative. It's on its way down. So -4. And how much is the x changing? It's changing by 4. So when you do it this way, the y will be positive or negative depending on whether you're going up or down, but the x will always be positive. And so the slope is -1. So now back to our y equals mx plus b. That's y is -1x minus 4. So that's our equation of the line. Now all of these answers, these are in standard form. Standard form is ax plus by equals c. So we have the right equation. We just have to get it into the format that the question is asking for. So we can add 1x to both sides. And that would give us this right here. X plus y equals -4. So the answer to number 9 is C. So now we're going over to number 10. Okay. So question number 10 is kind of dropping a keyword on us, something that we want to be really aware of. It's asking us about the moment that we cross the y-axis. So we're crossing the y-axis, and they're going out of their way here to tell us that that's the moment when x is 0. But we need to know that as a general rule. The x-intercept is the place where y equals 0. The y-intercept is the place where x equals 0. So here we'll just put x equals 0 because they're asking us about the y-intercept. So y equals 2, 0 squared plus 10 times 0 plus 12. So we get 0 plus 0 plus 12. So what's the value of k? In other words, what's the y-intercept? It's 12. So the answer to number 10 is D. Now we're going to 11. So here they're just asking us for the equation of a circle, and you should definitely know this equation by heart. The SAT asks about it often enough. So this is the equation of a circle. X minus h squared plus y minus k squared equals r squared. And when you're doing this, h and k are, one second here, h and k are the center, and r is the radius. So x minus 5 squared plus y minus 7 squared equals the radius squared. So 2 squared is 4. So we're going to have x minus 5, y minus 7, and 4. So the answer for number 11 is A. Now we're going over to number 12 here. ABC is similar to DEF. What's the value of the cosine of E? Well, what does similar mean? Similar means proportional. There are corresponding parts. Similar can also be meant to say that you have the same shape, but with a different size, and that size can be found often using a scale factor. But the idea is that if the sides are in proportion of 12 to 5 to 13, 5, 12, 13, then whatever these sides are, they're going to be in a proportion of 5 to 12 to 13 as well. So whatever is the cosine of E is also going to be the cosine of B, because they're proportions, they're proportional, and trig ratios are nothing more than proportions themselves. So whatever we get for the cosine of B, that's going to be our answer. So in the phrase SOHCAHTOA, you have sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. So since our angle is B, we go across from B, and the one that's across we call our opposite. The hypotenuse is the hypotenuse. It's across from the right angle. And then in trigonometry, the one that's left over, that's your adjacent side. So we have opposite across from the angle that we're talking about. Hypotenuse is across from the right angle. And adjacent is going to be the one that's left over. So we're looking for the cosine of that angle. So cos is the adjacent over the hypotenuse. And for the triangle with B, the adjacent is 12, the hypotenuse is 13. And so our answer is B, because whatever we get for angle B, it's going to be the same thing for E because they correspond to one another in that manner. So the answer for 12 is B. And we're moving right along here. 13. So we're talking about the x-intercepts. And we said a moment ago, the x-intercept is the place where y equals 0. The y-intercept is the place where x equals 0. So we're talking about the x-intercept here, which is where y is 0. So our x-intercept here, we're going to go ahead and say that means that y is 0. So we'll set it equal to 0. Okay. And now this is a quadratic form, a quadratic equation. It's a quadratic because it has y to the first power and it has x squared. So quadratics, we always solve them by setting equal to 0 anyway. But setting it equal to 0, that's our permission to factor or use the quadratic formula or complete the square, and all of these different quadratic solving methods that we talk about frequently. Having it equal to 0 is our permission to do that. So now we've got a quadratic trinomial, and it's got something in the B spot and something in the C spot, but nothing in the A spot. So what do I mean by that? A quadratic's in the format of y equals ax squared plus bx plus c. So we see numbers in the B and the C spots right here and right here. We don't see anything in the A spot. That actually means that A is the invisible number 1. But the 1 is okay, because if it were a 0 there, it would disappear. But this is going to be called BC factoring because we have something in the B spot and something in the C spot. For BC factoring, you're looking for two numbers that add to B and multiply to C. They need to add to B and multiply to C. So with our numbers here, we're looking for two numbers that add to 5 and multiply to 4. When you're doing this factoring, you always want to start with the thing it multiplies to, because there are not that many pairs of numbers that multiply to something, but there are almost infinite pairs of numbers that add to something. So what numbers multiply to 4? It would have just been 2 times 2 or 1 times 5, and 2 times 2 or 1 times 4, and 1 plus 4 equals 5. So this is going to factor to x plus 1 and x plus 4, because 1 and 4 are the two numbers that add to 5 and multiply to 4. And so now we have our zero product rule. So if you're dealing with quadratics, you'll notice a lot of the same stuff. This all seems complicated if you're seeing it for the first time, but as you get to practicing a lot, it's the same things over and over again. So the zero product rule says these two things, x plus 1 and x plus 4, multiply out to 0. And the only way they can multiply out to 0 is if one of them was 0. So the zero product rule says set them both equal to 0 and solve. So x plus 1 equals 0, x plus 4 equals 0, and go ahead and solve each one. So x is -1, x is -4. So we just found out now that our x-intercepts are -1 and -4. So this upward opening parabola is hitting the x-axis at -1 and -4. And what's the difference between them? Well, we could do -1 minus -4. So we're subtracting big minus small, and -1 is bigger than -4 because it's less negative. -1 minus -4 is the same as -1 plus 4. which is 3, and the distance is 3. So number 13 is C, and we're going on to number 14 now. What are all the values of x that satisfy the given equations? This one might be a little on the easier side because the only choices we have are 1, 9, or neither. So I would maybe recommend a couple of ways to do this. So if we start with the more sort of mathematically fundamental way, it would be to square both sides. X minus 3 squared means x minus 3 times x minus 3. So we'll just write that out. We can FOIL this, x squared minus 3x plus 9. Combine like terms, x squared minus 6x plus 9. Now, this is a quadratic, so we say that to ourselves to remind ourselves that a quadratic has to equal 0. So we're going to go ahead and take this and set it equal to 0 by subtracting 4x from both sides. 0 equals x squared minus 10x plus 9. And now we're right back at our BC factoring because we've got a number in the B spot, which is negative 10, a number in the C spot, which is 9. And in the A spot, we've just got the invisible number 1. So BC factoring, we need two numbers that add to B and multiply to C. They need to add to negative 10 and multiply to positive 9. So what two numbers do that? Well, 1 and 9 and 3 and 3 are the numbers that multiply to 9. So 1 and 9, if the signs are correct, will add to negative 10. So it factors to x minus 1 and x minus 9. So just another little word about the signs of all that. We knew that it multiplied to a positive. So things only multiplied to a positive when the signs are the same. So two positives and two negatives would both multiply to a positive. So we know the signs are the same. And if they add to a negative, then that means that they're both the same sign and they both must be negative because they add up to a negative. So that's kind of our hint that led us to get negative 1 and negative 9. The zero product rule is the thing that says that right here, you have two things that multiply out to 0. So you set each one equal to 0 independently. X equals 1, x equals 9, and we get our two answers that way. Now, super duper important here is that for radical equations, you need to check your answers. You need to plug them back in. So a lot of times these are just traps that are set for us to get 1 and 9 as our answers and go ahead and pick choice C. Now, choice C might be the right answer, but we don't know until we plug them back in and make sure that they're the right answers. So I'm going to go ahead and plug in 1. Square root of 4 times 1 equals 1 minus 3. So square root of 4 equals negative 2. Now, technically speaking, the square root of 4 is plus or minus 2, but we're supposed to be trained to not pick a radical equal to a negative number. So a radical equal to a negative number is very bad as far as just our training. And we could have a really long discussion of why, but just know by heart that that situation is wrong. And square root of, now we're plugging in the 9 to check it. So square root of 4 times 9 equals 9 minus 3. So square root of 36 equals 6. So now you have a radical set equal to a positive, and that is okay. And so the 9 worked, but the 1 didn't. And so the answer to number 14 is B for boy. Moving on now to number 15. In the system of equations above, A is a constant for which the following values of A does the system have no solution. So here we know we're dealing with two lines because we talked about how a quadratic will have y to the first power and x to the second power. A line is going to have both x and y to the first power. So these are two lines. And there are three ways that two lines can interact with one another. And that's what we're kind of being asked about here. Do we know the three ways that two lines can interact? They can hit once, they can hit never, or they can hit all the time. In other words, you can graph the first one, and when you go to graph the second one, you realize that it was actually the same line all along. So this is one solution, our situation that has one solution, 0 solutions, and infinite solutions. So here they're telling us we're looking for no solution. So that's a code for us to realize that they're telling us the lines are parallel. 2 parallel lines will never hit, they'll have no solution because the solution is the intersection. So we have 2 parallel lines, and if we know they're parallel, we want to get them in a y equals mx plus b format. So we're going to solve for y, and we're going to set the slopes equal to one another. So let's go ahead and do that for the first equation. We'll have negative 3x plus y equals 6. Get y by itself, so add 3x to both sides. So y equals 3x plus 6. The slope is 3. For the other one, subtract ax from both sides. So you have ax plus 2y equals 4. We're going to subtract ax from both sides. 2y equals negative ax plus 4 divided by 2. Y equals negative ax over 2 plus 4 over 2, which is 2. Now for the ax over 2, we have to kind of know that a times b over c can also be written as a over c times b, or it could also be written as b over c times a. And the reason is because b is really the same as b over 1, or a is really the same as a over 1. So in this question, when we have negative ax over 2, we could really think of that as negative a over 2 times x over 1. And so that's the same as negative a over 2 just times x. So that's a long explanation for something that's kind of easy, but if you're really familiar with this, you'll just immediately just write this as negative a over 2 times x. And the reason why you want the x universally there is because that'll give you the y equals mx plus b format. Here, y equals this thing times x plus 2. So what's the slope in that situation? It's negative a over 2. So we said we were going to set the slopes equal. So we'll say 3, one of the slopes, equals negative a over 2, the other slope. So now to solve for a, we'll multiply both sides by 2. 6 equals negative a. And multiply both sides by negative 1. A equals negative 6. And so the answer for number 15 is A. Going over to number 16 now. Here, just a very big word problem. This question reminds me of our viewer, Jaden, who is asking for some help with word problems here. And so this is kind of what comes to mind with me when you ask about word problems. But overall, something that the SAT is doing is just giving us a lot of words and a lot of complicatedness, sort of to kind of intimidate us and maybe kind of make us want to give up, it seems like. But when you have lots of variables, you can be advantaged by naming them, because this will help you think more clearly. So what are T, what are C, and what are F? T is the shipping cost. F is the number sent to the farther location. Farther or further? Oh, okay. F is the one sent to the farther location, and C is the number sent to the closer location. So they're giving us the formula, and the total cost is 3,000. So that's T is 3,000. 3,000 were sent to the further location. So F is 3,000. And 5C we still have there. So we plugged in for T, we plugged in for F, and now we need to solve for C. So we can do 12 times 3,000. And I'm actually noticing an error in what I filled in. The total wasn't 3,000, the total was 47,000. So apologies for that. Okay, so here we have 47,000. equals 5c plus 12 times 3,000, which is 36,000. Taking away 36,000 from both sides, we have 11,000 equals 5c. And now we're doing 11,000 divided by 5. So we're dividing both sides by 5 to solve. So you get 5 times 2, which is 10. Subtract, and you get 1 with a 0. 5 times 2 equals 10 again. And now you have nothing but zeros. So 10 right here, subtract 0, and we just have zeros that come down. And so we just fill the rest of the spots with 0. And the answer is 2,200. So now we're going to number 17. So A and B are the solutions. What's the value of absolute value of A minus B? So a lot of moving parts here, but we do need to know that in a situation like this, we have the two scenarios. So that's a major checkpoint if we're working with a student and trying to figure out if they're SAT ready. They need to know that in a situation with an absolute value equation, you remove the absolute value symbol and just leave it like that. And on the other side, you remove it and set it equal to a negative. So we need to know that if you have the absolute value of 2x plus 1 equals 5, then that's going to split into 2x plus 1 equals 5, 2x plus 1 equals negative 5. So there's your negative sign right there, nice and big. 2x plus 1 equals 5, 2x plus 1 equals negative 5. Now, why is it that it splits into a plus and a minus, if anyone's wondering? The reason is because the absolute value of a number, if it's positive, will equal the number. But the absolute value of a negative, it will become positive. Or if it were positive or 0, it stays the same. If it's negative, it becomes positive. So if I see that the answer to an absolute value equation is equal to 7, I don't know whether the ingredient that went into that was positive or negative. So in this situation, that's what we're doing. We're saying we don't know if 2x plus 1 was positive or if 2x plus 1 was negative. So we're kind of playing both sides. So now we're solving each one. You can take away 1 from both sides, and you can divide by 2 on both sides. Here you can take away 1 from both sides again, divide by 2 on both sides. So you get 2 and negative 3. So they're saying A and B are the solutions, and they're not specifying which. So we'll say A equals 2, B equals negative 3. And what's the absolute value of A minus B? That's the absolute value of 2 minus negative 3. And that's the absolute value of 2 plus 3, which is 5. And the absolute value of 5 is just 5. So the answer to number 17 is 5. Now we're going on to 18. Juan purchased an antique that had a value of $200. The value is estimated to increase 10%. The estimated value 2 years after is equal to 200A. So I'm not reading word for word, and that's a huge skill you always want to refine on the SAT, is the ability to get value out of something, to get comprehension without necessarily reading word for word, which is more time consuming. It's a nice balance of kind of being able to do that and also be as careful as possible. But what are they talking about here? They're talking about exponential equations. Exponentials are in the format of y equals a times b to the x power. So a is your starting value. B is how much it's changing in terms of what we're multiplying it by. And x is the number of times. So this will often be really relevant in terms of percents. And so what we mean is if we're increasing 10%, percents are different from other numbers that they always start as 100%. So if I'm increasing 10%, then I'm adding 10% to the 100%, and it becomes 110%. But if I were taking away 10%, it will go from 100 down 10, it will go to 90%. So we're either going to have 110%, which in decimal form is 1.1, or 90, which in decimal form is 0.9 or 0.90. So just beware when you're dealing with percents that you have to start at 100, and to change something by a percent, you add or take that away from 100. So now let's fill in the pieces into this situation they have here. We have something that has a $200 initial value, and it's being increased by 10%, so 1.1, like we explained in green there. And that's happening 2 years. That's happening 2 times. So this is 2. This is saying that we're going to increase it by 10% twice, multiplying it by 1.1 times 1.1 again, which means we're doing it twice. And I just noticed a little sort of typo here in my writing, because we have 200 as the starting, and we're multiplying that by 1.1 2 times. So this is our exponential equation. And normally we would just write y right here. But the question tells us that when we do this, this is equal to 200a. So 200a. And now we're solving for a. So one thing I might do to start this is divide both sides by 200. It's kind of a low-hanging fruit right there. 200 equals 1.1 squared. And now whatever 1.1 times 1.1 is, that's our answer. So a little long multiplication here. 1 times 1 is 1. 1 times 1 is 1. 0. And now we're multiplying these two. So 1 and 1 again. So we get 121. And there's 2 spaces after the decimals above. So we're doing 2 spaces worth of decimals here. So it's 1.21. And that's the answer to number 18. Now we're going over to 19. In this system of equations, what's the value of 5x plus 5y? So we are definitely going to be doing lots of work on elimination and substitution and so on. But before you start that, you would just want to kind of take the 2 equations and check if just adding or subtracting straight down is going to give us our answer. And it is here, because if I just add what we have, 2x plus 3x is 5x, 3y plus 2y is 5y, 1200 plus 1300 is 2500. So 5x plus 5y is equal to 2500. And that's our answer for number 19. So a nice little shortcut there without having to actually find x and y and then solve for them, which would have taken us much longer. So here we're dealing with differences of squares again. So we have differences of squares because we have u squared and t squared. Those are perfect squares with a minus sign in between. Difference of squares is the idea that a squared minus b squared, literally a difference of 2 perfect squares, is going to factor to the square root of each piece, a plus b and a minus b. So that's the idea of our difference of squares. And if we're applying that to this problem, super easy when you know what the problem was sort of intending for you. But we'll have u minus t times u squared minus t squared, which factors to u plus t times u minus t. So that's how this thing here factored to this. And the question is telling us that u minus t equals 2, u plus t equals 5, and then u minus t once again equals 2. So it's 2 times 5 times 2, 10 times 2, which is 20. And the answer to number 20 is 20.